Welcome to EDU World Space.
We're asked to find the perpendicular distance from the diagonal AD and the line of action BH, the tension on the cable BH. And what I'm circling in red are values that we've calculated in a previous problem that the problem is referencing. So these are calculated in a separate problem, and we're asked to use these values in this problem. So to start with, I'm gonna first find the parallel component of this force vector. So I'm gonna label that as T1. So the parallel component of this force vector, we can do the dot product of this unit vector. So this unit vector dot the tension vector of BH. So the unit vector dot the tension vector and this will give us a parallel component of 300 newtons. Okay, next we're going to find the perpendicular component of this tension vector. So we can write that out as the magnitude. So the magnitude of the tension vector is equal to, and since we already found this parallel component, we can do 300 squared plus T2, which is our perpendicular component, squared, all under the square root. And we know this value of the magnitude since it's given to us by the problem, this value here. So we can write this as, so we can set this equal to 450. And we can now solve for this perpendicular tension component. So we can rewrite this. So we rewrite this as T2 is equal to the square root of 450 squared minus 300 squared. And that will give us a value of 335.4 newtons. And since we've calculated this value, we can use that in the following equation. So the moment on the AD rod is equal to the perpendicular force component times our angle d, times our length d, which is what we're trying to solve for. So we know T2, and we also know the moment. So we plug in what we know. So the moment was -90, and we set that equal to 335.4 times d, and then solving for d. So we solve for d, and that will give us an answer of 0.27 meters.